Hi students, today I will give an important concept trick to find hybridization. Here hybridization to find how we can get hybridization very easily. In this first and very important thing we need to know about the hybridization. This hybridization is equal to, it is steric number. It is also called as, some books they may give it as a steric number. So you simply remember this as a steric number. Hybridization is equal to steric number. We need to calculate the steric number. Here steric number is equal to 1. Okay, we are not having 1 actually. So steric number is equal to 2. Then the hybridization is equal to sp. If steric number is equal to 3, then the hybridization is sp2. In the steric number is equal to 4, then the hybridization is equal to sp3. If the steric number is 5, the hybridization is sp3d. If the steric number is 6, then the hybridization is sp3d2. If the hybridization steric number is 7, then the hybridization is sp3d3. So first to get the hybridization, we need to calculate the steric number. So what is the steric number means? That is the value we are getting and how to calculate the steric number for a particular molecular ion. Particular molecular ion, how to calculate the steric number. So here please remember simply steric number is equal to that is equal to simply number of sigma bonds plus number of lone pairs okay, lone pair electrons simply, or number of sigma bonds plus number of lone pairs, or some books or somebody that gives like number of terminal atoms. The number of terminal atoms is equal to number of sigma bonds. So steric number is equal to number of sigma bonds plus number of lone pairs. If you know this number of sigma bonds plus number of lone pairs, then we will get the steric number value. If you are getting the steric number value, then we can say the hybridization easily. Or number of terminal atoms plus number of lone pairs. Please remember number of terminal atoms plus number of lone pairs. Again, we have lone pair number definitely. So either steric number is equal to number of sigma bonds plus number of lone pairs, or number of terminal atoms plus number of lone pairs. Please remember this formula. This is the important formula. So when we calculate the steric number, we can get the number of hybridization of that particular molecular ion. How to calculate this number of sigma bonds or number of lone pairs in a molecule given? I will give it directly, simply. So in finding steric number means this is considered as a S value. The steric number S is equal to number of sigma bonds plus number of lone pairs. We need to know about the elements to which group they belong. Mainly few means first 3 or 4 periods are enough actually, because we are having so many molecules obtained from first 3 periods only. So or after final or after second year, suppose if you see first year we study about the first year group, second year group, third year group, fourth year group elements. In second year you study about the fifth year group, sixth year group, seventh year group, zero group, D block elements, F block elements also. So in the entire 2 years process, we will completely learn the entire periodic table. So you can easily identify the position of element, the particular group or particular period. Or there is a separate method also to find the position of element belonging to a particular group or period, that is discussed in the periodic table chapter. You leave about that. And then now it is better to know about the element position in the periodic table and the group number of that mainly. group number of that element mainly. Here I gave already the first A group elements, hydrogen, lithium, sodium, potassium, rubidium, cesium, and second A group elements, beryllium, magnesium, calcium, strontium, barium. Third A group elements, boron, aluminum, gallium, indium, thallium. Fourth A group elements, carbon, silicon, germanium, tin, lead. Fifth A group elements, nitrogen, phosphorus, arsenic, antimony, bismuth. Sixth A group elements, oxygen, sulfur, selenium, tellurium, polonium. Seventh A group elements, fluorine, chlorine, bromine, iodine, astatine. And zero group elements, that is helium, neon, argon, krypton, xenon, radon. These are the total groups we are having, that is S block and P block mainly I wrote. This is S block, this is S block elements, and the remaining these are P block elements. Okay, and here if the group valency electrons, if you are taking first A group element means valency is 1, maximum valency 2, and this is 3, and this is 4, and this is 5. How we can say sir valency? That is simply you learned it, or you can go through the valency shell electronic configuration. For the first A group elements, what is the configuration? NS1. How many electrons is present? 1 electron. Here it is NS2. The maximum number of electrons in valency shell is 2. So this is the valence electron number. So valence electron number of that element is important. If you know the valency shell electron number, you can find the steric number very easily and accurately. So please first try to learn the valency shell electronic configuration of a particular element. Means if it is belonging a particular group, if you know, then we can find the electron configuration easily, and basing on that valency electrons we can write easily. So for example, we know very common and best example, that is a CH4 molecule. What is the steric number, or what is the hybridization of this CH4 molecule? So first, to find the hybridization of CH4 molecule, I need the valence electron number of central atom. Here the central atom is what? Carbon atom. The central atom, carbon belongs to which group? C, it is fourth group element. So when it is fourth group element, you please write 4 electrons which are present in the valency shell. Sir, there is a 2s2, 2p2, means one is pair, one is 2 is singular. When I are going to the first excited state, it gets unpaired electron. So please write them as simple electrons only, not paired or unpaired. First write the electrons number. And then you remember one more thing, always hydrogen, when we are taking hydrogen, here I am writing hydrogen, when we are taking, its valency is always 1. And next, all halogens means fluorine, chlorine, bromine, iodine. Its valency, or how many electrons it can donate for bonding, is 1. And next, oxygen atom always try to donate 2 electrons in this oxides forms. Please remember there is some exceptions, peroxide, superoxide differently. Okay, when we are taking normally, very commonly oxygen, how many electrons it gives for bonding means 2 electrons. And next, nitrogen, if you are taking, this is 3 electrons. And sulfur also generally gives 2 electrons. We will see later about that. So first of all, you remember these 3 first particularly. Hydrogen, how many electrons it can donate, or how many electrons in the valency shell of hydrogen? Only 1. So it can donate that 1 electron for bonding. And X means halogens. All halogens form single bonds. Okay, single bond mainly with other atom. And oxygen forms mainly double bond. Okay, if nitrogen is present, if it is bonding with any other, means it is a central atom. It is a central atom means valence is 5. If it is a terminal atom, then it can make a maximum of 3 bonds with the central atom. Okay, if they are terminal atoms, then they are forming such type of bonds. So this 1, 1, 2, 3 are when hydrogen is a terminal atom, where halogen is a terminal atom, when oxygen is a terminal atom, when nitrogen is a terminal atom, then only they make this type of bonding. Okay, and in the CH4 molecule, how many hydrogens we have? 4. So 4 hydrogens when we are having, so each hydrogen I am writing 1, 2, 3, 4. So each hydrogen has one electron now, 1, 2, 3, 4 electrons. So each hydrogen can make how many bonds? One bond. So this is one bond, one bond, one bond, one bond. So how many single bonds are present? Means between carbon and one hydrogen, one single bond is present. So this is sigma bond. All single bonds are sigma bonds. Very, very important thing. All single bonds are sigma bonds only. In between this carbon and hydrogen, another sigma bond. And in between this carbon and hydrogen, another sigma bond. And between this carbon and hydrogen, another sigma bond. So how many sigma bonds we have? 4. So the number of sigma bonds is equal to 4. Is there any non-bonded electrons on the carbon atom? No. So lone pair number is equal to 0. So total number of bonds, sigma bonds are say 4. So steric number, how much you will get? 4. When steric number is 4, what is the hybridization? It is sp3. sp3 hybridization. Okay, and next, suppose I am taking BCl3, BCl3 molecule, boron trichloride. Here in the boron trichloride molecule, boron atom belongs to, see, boron atom belongs to third group. So what is its valency? 3. 1, 2, 3. 3 electrons are present. Okay, and how many chlorine atoms are there? 3. Each chlorine or halogen gives 1 electron for bonding. So here, chlorine, 1 chlorine atom giving 1 electron, second chlorine, another electron, third chlorine, another electron. So, how they make a bond? Between this boron 1 electron and chlorine 1 electron, there is a single bond, another single bond, another single bond. And remember, all single bonds are sigma bonds. Okay, how many sigma bonds we have? Sigma bonds number is 3. Is there any lone pair? Means on boron atom, is there any non-bonded electrons? No. So 0. So steric number, how much we are getting? 3. Steric number 3 means it is sp2. We can check this BCl3 we gave in sp2 hybridization concept. Okay, and next, if you are taking a beryllium chloride, BeCl2 molecule. In BeCl2 molecule, beryllium, central atom is beryllium. Beryllium belongs to which group? Secondary group. So how many electrons it is having? 2 electrons. How many chlorine atoms we have? 2. So each chlorine gives 1 electron. So how many bonds they are forming? One bond and here another bond. So this is one sigma bond, this is another sigma bond. Total number of sigma bonds are 2 and the lone pair number is 0. Beryllium is not having any lone pair. And so steric number is 2. So what is the hybridization? sp. So here carbon CH4 is having sp3 hybridization. BCl3 boron is having sp2 hybridization. BeCl2 is having sp hybridization. So this is the way to calculate the hybridization very easily. And in this, we can calculate the number of lone pairs, number of bond pairs also. Please check here. How many sigma bonds we have? 4. 4 bond pairs only. Is there any single electrons, non-bond electrons? No. So lone pair number is 0. When you know lone pair number and bond pair number, we can calculate the shape easily as per Vsepr theory. Okay, so first you need to calculate the steric number value, find the hybridization. Okay, after that, if there is no lone pairs, then go for the shape as per the hybridization only. As per the hybridization only, I am telling. If there is no lone pairs, as per the hybridization, what is the sp hybridization shape? We gave for sp hybridization, the shape of the molecule is given as linear. and the bond angle I gave 180 degrees. No change because lone pair is 0. And here BCl3, no lone pairs, please see. And what is the hybridization? sp2. And what is the shape I gave for this sp2? Trigonal planar. Please check the hybridization concept. Trigonal planar shape. Triangular planar or trigonal planar. And what is the bond angle I gave? That is 120 degrees. So, when there is no lone pairs, just to see the steric number and the hybridization, as per the hybridization, what is the shape we have? That is only the final shape or geometry of the molecule. Here, for this sp3 hybridization, what is the shape? Without lone pairs, it is tetrahedral. It is a tetrahedral shape and the bond angle I gave 109 degrees 28 minutes or 109.5 degrees. So please remember one thing. First of all, find the steric number. Find the steric number. If you find the steric number, then we will get the hybridization. Then check it whether it contains a lone pair or not. Lone pair means where? As per Vsepr theory, on the central atom. On the central atom carbon, 4 electrons are present in the valence shell, 4 are participated in the bonding with hydrogen. So, what is the CH4 molecule? How we can write? You can simply imagine the CH4 structure. This is 1, this is 2, this is 3, this is 4. 4 bonds are present now. I wrote 1, 2, 3, 4 bonds only. Similarly, BCl3 structure means what they gave. Here, see, this is B, chlorine, and this is another chlorine. This is another chlorine. This is BCl3 molecule structure. Okay. And BeCl2 molecule structure, beryllium chloride. This is the structure. So here for these 3 bonds we wrote, and here also 2 bonds we wrote, 2 bonds are there. So steric number gives the clear values. Steric number, if you know, then basing on that, if lone pair is 0, according to hybridization, whatever the geometry we are getting, that is the final geometry for the molecule, no deviation. No change in the geometry or shape of the molecule. Even as per Vsepr theory also. If there is a lone pair, what happens? As per Vsepr theory, there is a lone pair, bond pair, lone pair, lone pair, or bond pair, bond pair. Repulsions will exist. Because of this repulsion, there is a deviation. There is a deviation in the shape, in the geometry of the molecule. There is a chance for the deviation in the bond angles also. Okay, first I will give as per the hybridization concept. As per the hybridization concept, if only bond pairs are present, bond pair means you can consider as sigma bonds also. You can consider them as sigma bonds also, sigma bond pairs also. You go through the table, then we will go for the lone pairs if present. Okay. Please remember this table for finding hybridization. So better to know about this first, and then you check this basing on the steric number you are getting. Steric number, how we can calculate means number of sigma bonds plus number of lone pairs. How we can get the sigma bonds means all the single bonds formed is sigma bonds. Sorry, you said only sigma bonds, single bonds only. If there is any pi bond is present, what happens? I will give one more example. Suppose simple example, we will go CO2 molecule. CO2 molecule, carbon is central atom, 1, 2, 3, 4. What I said, oxygen forms a double bond. Oxygen can donate 2 electrons and forms a double bond. So I am writing oxygen. Here one oxygen atom I am writing, it can form a double bond. Another oxygen I am writing, it can form a double bond by giving 2 electrons. So this is one double bond and this is another double bond. So please remember, for each oxygen how many bonds we have? One bond, double bond is there. In a double bond, I said already, if there is one single bond, always it is sigma bond. If there is a double bond, one is sigma, another one is pi bond. And in this also, this is a double bond, one is sigma, another one is pi bond. So, for steric number calculation, what we are considering? Only sigma bonds. Sigma bonds, how many we have? 2. Plus, is there any lone pairs on central atom? No, because all 4 electrons participated in the bonding. So, 0 lone pair. So, steric number is 2. Steric number 2 means what is the hybridization? SP. SP hybridization. So please remember, while we are writing with oxygen or with nitrogen, in that each oxygen, here please remember, each oxygen forms a double bond. Double bond means it gives 2 electrons for bonding and 2 electrons of carbon is participating. So what is the CO2 structure? This is the structure of CO2, original structure of CO2 molecule. Please remember. In this, one is sigma, this is sigma bond, and this is sigma bond, this is pi bond, this is pi bond. So, two sigma bonds are present. So, steric number is 2, sp hybridization. Okay, bond angle is 180 degrees. In this way, we can calculate. How we can calculate for NH4 plus molecule hybridization? Sir, you gave neutral molecules, okay? For ions, how we can calculate? You may have a doubt. So for NH4 plus, first I am writing what is central atom in this? Nitrogen, very good. Nitrogen belongs to which group? Fifth group, 5 electrons. 1, 2, 3, 4, 5. So please remember, NH4 plus means what? It lost 1 electron. It is losing. It gave. That is, electron is given already. So you don't consider this electron. That is lost by this nitrogen. So how many electrons it has? Only 4 electrons. Next, what are the bonded atoms? Hydrogens. So here hydrogen atoms means how many we have? 4. One hydrogen, this is second hydrogen, this is third hydrogen, and this is fourth hydrogen. So each hydrogen makes a sigma bond. This is one sigma bond, second sigma bond, third sigma bond, fourth sigma bond. So how many sigma bonds? 1, 2, 3, 4. So steric number is equal to 4 plus, is there any single electron lone pairs? No. So 4 plus 0, the steric number you are getting 4. 4 means it is sp3 hybridized. Here also, is there any lone pair? 0. So what is the shape? Tetrahedral. What is the bond angle? 109 degrees. And I will give one more example. H3O plus. In this, what is the central atom? Hydrogen or oxygen? Oxygen. Here oxygen is the central atom. How many electrons present in the oxygen? Central atom oxygen, 6th group, 6 electrons. I am writing 6 electrons for oxygen. 1, 2, 3, 4, 5, 6. And please remember what is there on charge? Plus. Plus means it is losing 1 electron. It is losing this electron. So remaining 5 only it is present on it. Okay. Now here H3O, hydrogens how many we have? 3. So when 3 hydrogens we have, this is 1 hydrogen, this is second hydrogen, this is third hydrogen. Okay, this is 1, this is 2, this is 3. 1 sigma bond, second sigma bond, third sigma bond. 3 sigma bonds we have. So what is the steric number we are getting here? 3 sigma bonds plus, is there a non-bonded electron pair? Yes, you have. Please see, this is one lone pair. This is one lone pair. So we have one lone pair. So totally, what is the steric number value we are getting? 4. Steric number value 4 means what is the hybridization? sp3. But what is shape? sp3 means tetrahedral, no? Is this having tetrahedral shape? No. It is not having tetrahedral shape. Because why? It has a lone pair. As per the Vsepr theory, if there is any lone pair, there is a lone pair, bond pair repulsions. Because of lone pair bond pair repulsion, the shape will change, geometry will change. So I will give the geometry as per the table of Vsepr theory. It is having pyramidal shape. I will give later, that is the shape basing on the lone pairs present. Okay. First I will give the table without lone pair. When there is a hybridized orbitals only bond pairs, no lone pairs, only sigma bonds present. Then what is the geometry, what is the bond angle? The second table I will give with lone pair and deviation in the geometry and bond angle deviation is present. Okay. You can check this table in the NCERT textbook also. Okay.